Hello everyone. Today we're going to be talking about compound inequalities. Typically called and or inequalities. So let's just jump right in. Compound inequalities are two or more inequalities graphed together. On the same number line. And let's look at it. This type 1 is or, so we're looking at when x is one thing or another. So here in this graph, I see that x can be less than -4 or x can be greater than 1. But when I see that x is less than, it can also be equal to -4. Do you see that solid dot so you can see that? Or x is strictly greater than 1. And if I put that in interval notation, it looks like -infinity up to and including -4. But it's also the union between. So it's not just one interval, it is two intervals, 1 to infinity. So that U stands for the union between the two. And if you were putting it in set notation, we would define our x variable such that x is less than or equal to -4, or x is greater than 1. Let's look at these. Pretty straightforward. We're going to solve one and then the other. So this one is -4, -4. 3x is less than 6, divide by 3. X is less than or equal to 2. And this one we just straight divide by 5. We have x is strictly greater than 9. Easy to graph. We have 2 and a solid dot. And we have 9 and an open dot. And it goes greater than 9 or less than 2. And my interval will tell me infinity to inclusive union open 9 to infinity. Let's try another one. This one is so easy. -6 plus 7 plus 7. We got n is less than or equal to -1. This one is 9n is greater than 36. Divide by 9. N is greater than 4. And we have n is less than or equal to -1. So that's a closed circle. And it goes less than. And 4 is an open circle, and it goes greater than. And my intervals will be -infinity, -2, closed, union, open, 4, infinity. Not bad, right? Let's do number 3. -8, -8. -3y is less than or equal to -15. Divide by negative, you gotta flip the sign. So y is greater than or equal to 5. And y is less than or equal to -30. So when we look at this, we have -3. It's equal to it's a closed circle. And 5, it is a closed circle. And y is greater than or equal to 5 or less than or equal to negative 3. Negative infinity to negative 3 inclusive, union, inclusive 5, infinity. You should pause this video and try to do these next few on your own. I will give you the answer and highlight it and graph it. A is negative 6. A is greater than, A is less than negative 6, or A is greater than negative 1. And these are strictly less than and greater than. So we'll have open circles, and we go this way. You should do the work. You should try this. Negative infinity to negative 6, open, union, negative 1, infinity. All right. I think you guys are pretty good with these. If you want to try the other ones and come and talk to me, I say try it. Oh, you know what? Let's do number 6. So when it's in the denominator, we multiply by negative 3. Now remember, multiplying and dividing by negative, you got to flip the sign. 3 times negative 3. So these cancel out. It's 8 minus x greater than or equal to positive 15. Then I subtract the 8, and I have negative x is greater than or equal to negative 7. Still not by itself. I have to divide by negative 1. When you divide by negative, it's left with that sign. X is less than or equal to 7. Nope, negative 7. This is positive. And let's look at the other one. This one is here, so I'm not going to deal with that fraction until I manage that 5. So minus 5, minus 5. I get negative 3 over 2, x is less than negative 6. Now there's a couple ways to get rid of this fraction, but we're going to multiply by the reciprocal. If you don't know what that is, that's okay. We'll learn. So the reciprocal is keep it negative. But if I multiply by one side and it's by a negative, I got to flip the sign times negative 2 over 3. What this does is it cancels this. Leaves me with x. If you don't know how to use the reciprocal, you could have multiplied by 2 and then divided by negative 3. It would have given you the same results. And for this one, it's 6 times 2 is 12, divided by 3 is 4. And it's negative times a negative, which gives us a positive. So those are my answers. Negative 7 inclusive, x is less than. 4 open, x is greater than. And my solution would be negative infinity minus 7 included, union 4, infinity open. All right, not so bad, right? Then we're going to get to our type 2. And our type 2 is the and. See, before we did or, now we do and. This one has a closed circle there and an open circle there. So I would say that x is greater than or equal to negative 2 and x is less than 5. My interval notation shows closed at negative 2 and 5 is open. And in the set notation, it'll look exactly like above. So our x is defined such that x is greater than or equal to negative 2 and x is less than 5. Because the solutions to an and inequality fall between two endpoints, they are frequently written in a more condensed form. Example, so when x is greater than or equal to -2, and x is less than 5, we can write that as -2 x 5. See how those x values fall in between. Now, if the and inequality is written separately, like in number 7, we solve each part separately like we've been doing. But if in like number 9, it's condensed together, you have to work from the inside out, Then graph to show all possible solutions. We're going to do number 7, then we're going to switch to number 9. And then we'll do number 12. And I think that might be it. So number 3 minus 3. This gives us 2x is greater than -12. Divide by 2, divide by 2. X is greater than -6. And plus 2, 8x is less than 32. Divide by 8. And we've got x is less than 4. And we will graph that. These are both open circles. So open at -6 and open at 4. And it is the and, so in between. And writing this open, -6, 4, open. Not bad, right? Let's see what it looks like when it's combined. So we work from the inside out. The variables with this one, so I'm going to add one here, but I need to add it to every side. And this would give me -1 is less than or equal to a, which is less than or equal to 7. And they're both closed. So -1 gets a closed circle. 7 gets a closed circle. And we're in between. And that would look like -1, 7, closed interval. What do you guys think? How's it going? You should try to do these other ones. I'm going to give you the answer to number 10, and I want you to try to solve it and tell me what it looks like. 0, 5. And it's open, 0, and open at 5. And I want you to show me the work. You can do that. Start with the middle. You know what? I'll do it with you. -4, -4, -4. 3p is less than 15 and greater than 0. Notice that 0. I have to divide by 3. Now it's not a negative, so I'm not flipping signs. But 0 divided by 3 is 0. Less than 3, less than 5. And thus, that gives me the graph. Let's try this number 12. Now, there's a divisor in here, but we're going to multiply by -2, which means I flip the sign times -2, flip the sign times -2. And doing so gives me 10 is greater than or equal to 12 minus x, which is greater than 4. Now I'm going to subtract 12. This gives me -2 is greater than or equal to -x, which is greater than -8. X is still not by itself, so I'm going to divide it by a negative. But that means I flip both the signs and divide each part by a negative. I'm left with 2 is less than or equal to x is less than 8. Did you have that? What do you think? 2 is a closed circle, and 8 is an open circle, and it is between them. And it would look like 2, 8. All right, we'll talk about this other stuff shortly, but I'm going to leave you with no homework for the weekend. Have a great weekend, and I'll see you soon.